We have previously restored a few AT clones on this channel, but we have still not taken on the original AT from IBM. Let's change this today and restore this 5170 from IBM. This machine came untested, so I don't know if it works, and I have not checked which variant it is, so let's explore it together. I can't see any major dents or scratches on the case, but it's quite grimy, so I can't really tell what the condition is until we have washed it. It looks to have the original floppy drive installed, but then it has a large gaping hole here. At the back here we have a 5170 badge. Behind this door I think we have a battery. This machine has a very high serial number. Unfortunately, someone snatched all the cards, so that's a bummer. But I think I have a few cards we can install in this machine. The international power supply has a really clean fan. That is not a common sight. So either someone has cleaned it, or it hasn't seen much use. If you think the 5150 is big, which I do by the way, the 5170 is quite a bit larger still. This is a big machine. Make sure to have a lot of desk space if you're on the market for one of these. The case has 5 screws at the back, just like the 5150 and the XT. Now that I think of it, this must be the largest machine we have worked on the channel, with the exception of the Model 80 tower that we restored a few weeks ago. This thing is huge. I think it's missing one of the feet, so we'll replace it later. Now let's get this lid off. Oh, we've got the original hard drive still in the machine. That's awesome. I love these hard drives, I hope it works. And there's actually one card left in this machine. And this is the hard drive and a floppy controller, both in the same card. Oh, we still have the battery installed. But I don't see any leakage. I think we're in luck. Yeah, I don't think this battery has leaked. I need to pause this video and go and buy a lottery ticket.
1 hour later.
Okay, I'm back. So what have we got? So we've got a date here. It's a strange 3-number date, but I think it's the 31st week of 1988. So that's quite late in the production. Or this battery has been replaced. But if it's replaced, it was replaced quite early on. Okay, first impression. This IBM is really clean. I can't see any dust. So it has either been used in a very clean environment, or perhaps not used much at all. You never really know when you open up these machines. Sometimes they are completely filled up with dust and leaky batteries, and sometimes you're lucky and they come clean like this. On top here we have a ground cable. This must be for the optional second floppy drive. Let's start by pulling this controller out. So I was expecting to do a lot of cleaning in this video, but it seems I was wrong. This IBM doesn't seem to need much cleaning. Well, except for that lid, of course. It's quite grimy. Wow, this card is huge. It's actually even larger than the controller in the 5162. So this card won't fit in many PCs, that is for sure. It's kind of strange that it's so big, because this card here has exactly the same functionality. This card has a small sticker with what looks like IBM numbers here. And then it says fixed disk and floppy diskette. And it has a bunch of bodge wires. Dates on most of the chips are from 1986. There are no screws underneath for the hard drive, like on the XT. So I think we need to remove this bracket here to pull that hard drive out. There are no screws on the side here. So let's try to push that drive out. Yeah, it's sitting on these rails here and it's free to come out. I'll disconnect the power and the 2 ribbon cables at the back. It also has an extra ground cable, just like the spare one here. Now let's pull that massive hard drive out. This thing is huge. This drive here is a Seagate ST4026. So that hard drive is the same type as the one we found in the 5162. The floppy drive is held down with these tiny brackets, one on each side, and nothing on the side here. This drive too has an extra ground cable, aside from the usual Molex and ribbon cable. That one almost came out and dropped on the floor. That is so clean. It always surprises me when I open up a machine from the 80s and it doesn't look like it has ever been used. I mean, these machines were insanely expensive back in the day. One would think that if someone would spend that kind of money, they would use it quite a lot, right? Well, not in this case. Well, there's not going to be much cleaning here, but we still need to check for refills and make sure everything is okay before we power the machine on. Power supply is about the same size as in the XT. Probably just slides out like this. Being the original AT, it obviously has AT connectors for the power supply. Now, this power supply I think is actually larger than in the XT. And yes, it definitely is. It's quite a bit larger. Underneath the power supply there is actually a handwritten date. It says TAL 86 week 9 and H. So apparently this machine was assembled in week 9 of 1986. As I mentioned before, I only need to wash the case. But there is a tiny amount of dust in here, so I might as well remove the motherboard and wipe that dust off. Just like the XT, this board only seems to have 2 screws. One at the back and one at the front here. And the rest is just clips. Yeah, as you can see, there's a tiny amount of dust. But that's nothing for a machine from 1986. I'll just have a quick go with the hoover inside here. The power supply is of course put together with security screws. It's a T20 with a hole and a corresponding peg in the screw. So 1986. So what do you guys think? Are we going to find a reefer inside here? I'd say the probability is quite high. Why the heck did they make this power supply so bloody huge? This thing is absolutely massive. Well, maybe that huge hard drive needs a power supply this large. Oh wow, that is clean. Yeah, just like the rest of the machine. This is a really clean power supply. So someone spent silly money on this machine back in 1986 and somehow forgot to use it. Go figure. Well, I think I can see the X cap from here and it's not a reefer, but I can't see the Y cap, so we need to get further inside. I'm gonna have to guess here. Let's start by removing this screw here. Well, that didn't work. How about if we try to hold it still? Yeah, that totally worked. Apparently we also have a couple of clips here. So let's try to undo these two. Why the heck did I install the safety caps all the way down at the bottom? I wish they knew back then that reefers would blow and smell, well, like only reefers do. Oh, this one is shorter. I'm gonna have to keep track of these. And then we have 2 screws on this side of the PCB. Why the heck did I tape down these caps? That's a bit strange. Well, I can't see the other screw, and it's down here in the corner. Next we need to move the cable here. And then pull that PCB out, because it's still stuck in these tabs here. Okay, we're in luck. There are no refills in this power supply, and we don't have to desolder any of the PCBs. It was enough to pull that PCB out just a little bit, and we can see the remaining board down here. So that's awesome. But seriously, the guy who designed this PCB, what the heck was he thinking? Placing the fuses all the way down here. You would probably have to desolder at least one of these PCBs just to access the fuses. That is silly. Oh, there is actually some dust on the fan here. So someone was using it, at least for a while. And there is what looks like a dead fly. No, there is some other bug. But this guy is dead. Probably since 1986. I also did visual inspection. And all the boards look okay. There are no bulging or leaky caps. And aside from that fan, everything is reasonably nice and clean. Now, this is quite a bloody coincidence. A viewer told me to check out these switches here for my PS2 projects. And check out what we've got in this power supply. That is exactly the same switch as these arrow switches here. So now we know what these are for. And if I'm not mistaken, they will also fit in the PS2. Although they are not perfectly identical. And apparently here's the reason why this case is so wobbly. The cork feet have come off and moved around underneath the case here. I'll heat them up with a heat gun and see if I can peel them off. Yeah, that totally worked. I'll use some IPA and see if I can scrub this glue off. Well, most of it came off, but the actual glue pad is still left on the chassis. So I'll use some more heat and see if I can peel it off. Yeah, that totally worked. When nice and toasty, glue is easy to remove. Okay, I got all the glue off. So now we can clean the underside of this machine too. Luckily, I found some new cork feet on Amazon. Yeah, that looks much better. No more wobbly case. And that was actually the last thing to clean up. So we can start reassembling this 5170. One common issue with these boards is popping tantalums. But I have a very good reason not to replace them today. It will be apparent why in one of the upcoming videos. By the way, there were 3 revisions of this motherboard. Now, this is the Type 2 board. As far as I can tell, it's identical to the Type 3 board, except for the 6 MHz 286 and the matching crystal, and also the BIOS revision. So we're obviously going to upgrade all 3 of those. If you know of any other differences, then please share. Time for the power supply. That screw in the corner was an absolute pain to reinstall. But aside from that, this was a piece of cake, of course. I only had to clean up that fan and put everything back in. And the usual disclaimer, please don't mess around inside power supplies. Some of these caps can be charged with high voltages, even with the cord unplugged. So let's go ahead and reinstall the power supply. We are going to do a few upgrades today. But first I want to do a quick test and see if this machine works. So let's reconnect that power supply to the motherboard and install the floppy drive. I think this case is designed to take 2 of these massive drives. So by removing this piece here, I think we can install the second drive underneath here to have a working drive for our tests. We're also going to need a controller. So let's install that huge card. Yeah, the ribbon cable actually has a spare connector for a second hard drive. And it sits underneath the floppy drive. Well, to display any graphics, we obviously need a graphics card. I'm a bit torn about what graphics to use with this machine. During its lifetime, these machines were used with all 4 standards: MDA, CGA, EGA and VGA. That's a bit too much to choose from. So what do you guys think? We're actually ready for a test now. So let's turn that display on and flip that power switch. Okay, the fan spun up and it's counting up the RAM. Awesome. So this is at least a partially working machine. 512 KB. System options not set. Awesome. And we're in basic. Well, since this restoration was so quick and easy, let's include some upgrades in this video too. The first upgrade I want to do is the BIOS. So I found the Type 3 BIOS on -0 degrees and I downloaded the 2 files. I'm going to use XG Pro, and this board takes two 27C256s. So let's load up the bin file for U27 first. And drop that EEPROM into the TL866 and program that chip. I'll add some labels so I don't mix them up. Some early boards had 4 EEPROMs for the BIOS, but this Type 2 board only has 2. They are a bit tricky to remove because this can here is in the way. I can't use the proper tool, so I'm gonna have to wiggle these out with a screwdriver. Okay, eventually they came off, and we can install U27 and U47 from November of 1985. With the BIOS from November of 1985, this machine now has full support for 3.5-inch high-density drives. Installing one of these is a huge time saver, since I have a 1.44 meg drive in my modern rig. To make it fit in this machine, we need a bay bracket. I don't remember if I bought this bracket on Amazon or if I bought it used on eBay. With this drive installed, I can download files and move them to this machine in minutes. The front base on the 5170 requires these rails. They are becoming more and more difficult to find, but if you have a printer, you can print these. Now there is one small problem here. The ribbon cable in this machine is designed for edge connectors, but this drive has pin headers, so that's a problem. Well, in that case, this is going to be a sponsored video, because I have a solution for this. We're going to need some help from my favorite sponsor, PCB AOYUE. I ordered these quite a while back, because I knew I would need them someday. And apparently that's today. It's a pretty simple project, but extremely useful. There used to be adapters like this you could buy, but nowadays they are pretty much impossible to find. But luckily someone designed these PCBs to help us out. I'll put a link in the description to where you can find this project. And as always, these PCBs look really classy. I highly recommend checking out PCB AOYUE for your next PCB projects. The only components on this PCB are edge connectors like this. I found these on eBay, but you can probably buy them from your favorite electronic supplier too. These are of course extremely simple to build. We just need to solder one connector. The correct side to add the connector is clearly marked in the silk screen. So the only thing we need to do now is to solder a few pins. I'm gonna build up a few of these because they're extremely useful in many projects. Okay, said and done. Let's clean these up. And here's the final results. Cleaned up and ready to be installed. Pin 1 is almost always on the same side as the power connector. If you're not sure, you can check underneath the PCB. And in most cases, pin 1 is marked, like in this case here. Pin 1 is also clearly marked on the adapter. So that means it goes in this way. The edge connector has a notch here, so you can only install it in correct position. We also need an adapter for power, because this machine only has Molex. This adapter is homemade, but you can easily find these on eBay. Okay, the drive is ready to go in. And it should fit perfectly. Yeah, that looks pretty good. That was a really lucky match. I can't see the difference in the color between the diskette drive and the bay adapter. And now the edge connector here should fit perfectly on our 3.5-inch diskette drive. I just noticed that the original drive is marked with a B here, so now we know why one of the bays was empty. This machine had 2 drives originally. Since this used to be the drive B, we probably need to change the termination. But I can't find the manual for this drive. It's a YD380. But I think it's a pretty good guess that this resistor pack here takes care of the termination. But let's try it like this first, and if it doesn't work, we'll remove this resistor pack. 3.5-inch drives usually don't need termination. Before we change any settings on this machine, we need a battery. I don't have any Velcro, so I'm going to reuse the Velcro from the old battery. Now what is this stuff here? Oh, that's disgusting. It's a dead bug. Something very long and disgusting apparently lived in here and died. Yuck. What the heck was it doing in here? It must have got stuck and dried up and died. I'm also going to reuse these wires with the connector. Apparently this is a 3-volt lithium battery. I soldered the connector to modern CR2032 holder. Let's add some heat shrink. This battery holder will take 2 CR2032s, and they are connected in series, so that should give us about 6 volts. I'm gonna cut that piece of Velcro and reuse it on our new battery holder. I could order some new Velcro, but then I would have to wait for shipping. Let's get some fresh batteries installed. Okay, battery connected. And we can mount it with the old Velcro. The only thing left to install now is that massive C-gate. Okay, let's start testing this machine. I'm gonna start with G setup. Let's see if it will boot from the 3.5-inch diskette. The hard drive woke up and it sounds good. Fingers crossed. I hope it works. And we're getting a diskette error. In that case, I'll disconnect drive A and we'll try again. This could be caused by the termination resistor. Okay, still doesn't boot. In that case, I'll move the ribbon cable and connect the twisted part to the 3.5-inch diskette drive. We'll try again. Okay, now the drive woke up. And the machine boots. I just realized perhaps it's better to have the 3.5-inch drive as drive A. So I'll connect the 1.2 meg drive as drive B. Said and done. I left the 3.5-inch drive as drive A and connected the 1.2 meg drive as drive B. And I left what I think is the termination resistor. Let's try again. And it no longer boots from drive A. So something is messed up. Well, it behaves a bit strangely. I installed the DOS diskette in drive B. And now it boots from drive A. That's a bit bizarre. Let's try again. With this floppy removed. That's bizarre. So with nothing in drive B, it won't boot from drive A. Oh, I just realized. We moved the jumper from DS1 to DS0. So they're both set to drive A. Okay, jumper moved. So drive B is now set to DS1. Okay, that fixed it. So now we can run G setup from drive A. Your CMOS RAM has lost power. Yeah, it has for sure. For a couple of decades. Now let's set this thing up. Okay, 1349 and 2024. And drive A is a 1.44, 3.5 inch drive. And drive B is 1.2, 5.25 inch drive. Oh, I forgot to check what type that hard disk is. Apparently IBM kindly enough provided the type by writing it on the sticker here. So this is a type 2 drive. So let's set it to type 2. And apparently this is a 21 meg drive. Next we have base memory. And we only have 512K so far. We'll add some more in the future. And display is already set to EGA. So let's exit and see if this works. Press enter to reboot. And error went away. Awesome. Now let's see if it will boot from the hard drive. Disk boot failure. Well, that's okay. It may just mean that it's nothing on that drive. Let's see if we can access drive B next. List the directory of that floppy. Yep, totally works. Okay, so we have 2 working drives. Let's fix that hard drive next. I just realized this machine is quite noisy with the lid off. So let's put that lid back on before we continue. So we got these 2 small brackets for our drive B. But only one of these brackets for drive A down here. And instead, the large bracket for the hard drive also acts as a bracket for drive A. Well, I guess that's the efficient way to do this. Now we can slide the cover on. Wow, that is a good looking machine. I never thought of it as a looker because it came so grimy and with a large hole at the front here. But now that it had a proper wash, this machine looks great. Well, if you're into vintage IBM design, it doesn't get much better than this. I think these machines primarily came with the Model FAT, but I think they switched to Model Ms at some points. In any case, I think it probably looks better with this Model M than the original FAT. This must have been like the Rolls-Royce of PCs back in the 80s. Imagine a market full of cheap XT clones. And then IBM releases this damn thing here, with that crazy price tag. Wow, with the display on top, it looks even more impressive. This thing is huge. I mean, this Atari display in the background looks like a toy, compared to this giant of IBM industrial design. The 3.5 inch drive looks great too. It kind of fits the theme. I thought it'd look a bit silly, since the original drive is in a different color, but I think this looks great. It doesn't look out of place at all. It looks like it belongs in the machine. Okay, let's see if we can make that hard drive come alive. I'll boot from SpinRite 5. Okay, viral infection self-test passed. Antiviral BIOS passed. System RAM memory test passed. Hard disk controller and floppy disk controller passed. So system seems okay. And it detects our drive C. And next the software is going to locate surface defects. I forgot to check, but I think that sticker on the drive was blank. Apparently we've got 4 heads, 17 sectors, 614 cylinders, and a total of 21.34 megabytes. And now it's running a whole bunch of tests of the drive here, so I'm gonna skip ahead here. The drive, by the way, sounds great, so no weird noises from this drive. Maybe that's a bit of a harsh wake-up from a couple of decades of sleep, but this is IBM industrial design. I'm sure it will cope. Most people seem to prefer XT IDE, but personally I love the weird noises these old hard drives make. Okay, SpinRite is doing its thing and showing some funky graphics, and the hard drive is making some interesting noises. So I'll skip ahead here. Okay, long story short, SpinRite crashed. I ran it again and it crashed again. So then I ran SpeedStore 6.5. SpeedStore found a few bad sectors. Nothing extreme, but a few of them were bad. And when SpeedStore was done, I went back and ran SpinRite 5 again. According to SpinRite, this drive's performance may be improved by 50% by changing interleave from 3 to 1 to 2 to 1. So this is why I wanted to run SpinRite before we moved on. I've never done any benchmarks with different interleave settings, so I'm not sure how much this improves the speed, but perhaps we'll do in a future video. Next I went back to SpeedStore again and changed the interleave from 3 to 1 to 2 to 1. So all that worked out well in the end. But then I ran into the next problem. According to -0 degrees, this machine should be able to run high-density disks in a 3.5-inch diskette drive, but it doesn't. Even with the BIOS upgraded, it still won't run 1.44 meg diskettes. I would ideally use the original BIOS, but I'm not sure we can anymore. I'm gonna have to do some reading and see if I can find out what the issue is here. So for now we're gonna go with DOS 5, just because I have it on double density disks. It's not a bad choice for this machine, so perhaps it gets to stay. But first we need to jump into FDisk and create a primary partition, and then format the hard drive. We still have 19.95 megs left on that hard drive, so not that many bad sectors. And the drive is still totally usable. Now we can go ahead and install DOS 5. And unfortunately, that was the end of this hard drive. DOS crashed, so I decided to run SpeedStore again. And unfortunately, it just filled up a complete page with bad sectors. So that drive is dead. Well, I guess I need to find a new drive for this project next. That sucks. Whoa, things just got interesting. I never had any issues changing to the recommended interleave that SpinRite recommends. But for whatever reason I decided to go back and change it to 3. And check this out. We're now back to this very reasonable list of defects on the hard drive. So now I'm going to go through some of my old hard drives and see if this trick works on those too. I tend to use FDisk to make partitions, but let's try SpeedStore for once. Automatically creates and format partition. Okay, so apparently this is slightly different from FDisk. It's also scanning the partition for defects. So maybe the software is better than FDisk. Well, for this machine to be fun to use, we need to do some upgrades. And eventually I think this project is going to end up as an overclocking battle against the 5162. If you're watching this sometime in the future, there will be a link on the screen shortly to the upgrade video. If you're watching this fresh, hit the bell icon below and set it to all. And now is a good time to watch this video. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, I'll see you next week.